I am audible to all of you. Any of you can respond. So I thought I will today will try to do a few of the problems, and they will be important for your exam. So I have just displayed a question. I would like you to attempt this. Anybody can volunteer to attempt this? Nobody is responding. Let us see. Anybody? You take your own time, read this question. I am also reading for you. A student measures mercury concentration parts per million in water samples from 10 tap water sources. She obtains following values: 1.1, 1.23. There are 10 values. Calculate the sample mean, sample standard deviation, and sample standard error for mercury data. Can anybody of you volunteer and say that you can solve this problem? If not, then it's okay. We'll discuss that. But I would like you to come forward and tell. What is happening? Go to that OBEX, you will ask. Also. What I have to do? Okay. Avinash Sahu. Avinash Sahu, can you hear me? Oh, unmute karo. Avinash Sahu. You सुन नहीं रहा? They are not recording. Huh? They are not recording. Avinash Sahu, can you hear me? Aishi Chakrabarti, any of you? Ananta Datta, Anupriya Chattopadhyay, Babulu Pradhan.
Yes, sir.
Can you respond? But I am asking a question, nobody is responding. Can you, tell your name and then you ask, let us look this problem. What is your name?
Sir, Anupriya.
Anupriya, yeah. So I have displayed a question. And in fact, this one is the last year's question. So I thought, let me start with this. And then we'll see. Can you answer this question? Is it okay?
Sir, calculating.
Yeah, this calculation only. So how to calculate?
So for sample mean, we have to take the addition of all the samples and divide it by the number of samples.
Okay, just a minute. Okay, we need to just hold on. I will just write it. What you are telling, I will just go on writing. Okay, suppose first I have to calculate the sample mean. So that I will calculate. This is okay. So I have written the mean, calculate the mean. This is okay.
Yes, sir.
How do I calculate the standard deviation? This is okay,
Yes, sir.
but this is wrong.
How?
Because because of this only I wanted you to look into this. When you are calculating a standard deviation for a sample, for a population, this is okay. But for a sample, you have to take n minus 1. Always remember this. Because of this only, I've asked you this. Most of people last year they committed this mistake. For a sample, when you want to calculate standard deviation, you have to use n minus 1. Okay. And then the third thing is, how do I define the sample standard error? Any idea? Don't remember? Okay, I will write. Okay, this, if you know this, then you can answer this question. This is a very simple question, but you have to do accordingly. So this is what just I wanted. This question was there in last year, and I think almost more than 50% have not able to answer. They have somewhere or else they have committed mistake. So if I recollect, okay, this is just I wanted to tell you all so that you be little bit try to see how these things are calculated. You may find some questions in the exam, then you have to answer those questions. So if I recollect, we had discussed on basically on data analysis, and where I told you how to calculate this mean and also standard error. I had also discussed. And another thing, you can go to the next page. Blank page. I had also told something called, maybe here, this page. What is called central limit theorem. If you remember, we had discussed this. What it says that when you are measuring a mean, the probability of finding mean, particular mean value. Suppose I write that P, this will follow a relation by V to the power minus Sample is mu. This relation I have told. So what it says, what is, suppose I do a measurement, I do of a sample. Good. Then I look at a normal distribution of the mean. Suppose there is a population, I am trying to measure the mean of the population. When I do, I look at a distribution, and this distribution will follow such a normal distribution, and where delta x bar square, which is basically the standard deviation, and this follow a normal distribution, and this is what is called as a central limit theorem. What it means, if this delta x bar, it reduces like this. Your population standard deviation divided by root n square. So as you take more and more measurement, your standard deviation will keep on reducing. So that is what your mean value is going towards the center. So that is what is called the central limit theorem. It's a very important theorem. So once you know that probability of measuring a sample mean x bar, as I say here, is given by a normal distribution, you can use this knowledge. This knowledge can be used to test hypothesis. That is what we had a little bit discussed last time. How we can use, particularly this central limit theorem, to carry out hypothesis testing. So just to simplify this calculation, we can redefine parameter z is equal to x bar minus mu. X bar. If you do this, then you can write, and you can rewrite this like this. How you interpret z here? Z is interpreted as the difference between sample mean and the true measurement. Suppose this is the difference between sample mean and the true measurement in the units of standard deviation. The units of standard deviation. Let us say when z is very large, if it is more than 1, then sample mean differs from the true mean. This is your sample mean, this is your true mean. So if z is more than 1, that means there is a difference between sample mean and the true mean. And if z is much less, then you can say that if the x bar minus mu difference is much less, then you can say that chance, due to chance, you can get a value like this. Like, that small difference one can get just due to chance, because your mean value has a distribution, and that is a normal distribution. And if this z value is small, then you can always say that this is due to chance. And if this z value difference is too large, then you say chance alone cannot explain this difference. So we will be using these ideas for hypothesis testing. Since I told you that this is a normal distribution, so basically what is happening, suppose I have distribution. This is Z is equal to 0. Suppose. And similarly, you can let those two. Since normal distribution, PZ is the probability distribution. So area under curve, if I take 1 sigma plus minus 1 sigma, this area under the curve gives the probability. And suppose 1 sigma is basically, we say 68%. Suppose I have two different measurement, and once I got a mean value, the mean value falls between the Z value plus minus 1. Then I can say that suppose I got a mean value somewhere here, 1. Then I can say that there is still 32% chance that one can get a value of Z is equal to 1 or more just by chance. Just by chance can give me that much value. So we'll use this concept, area under the curve, for our hypothesis testing. So what do you do for the hypothesis? How can this area of the curve used in practice for hypothesis testing? So what is hypothesis? What is hypothesis? A hypothesis must have one independent variable. It must have, remember this, must have one independent variable and at least one dependent variable. For example, if I say I want to study effect of fertilizer doses on tomato size, suppose I want to study effect of fertilizer doses on tomato size. So my dependent variable will be tomato size, and my independent variable will be doses of fertilizer. So the point of experiment is to determine if it does or does not change. Suppose hypothesis, I have to test the hypothesis in the sense I have to see when this fertilizer is applied, doses are applied, whether really my tomato size changes or not. That is the hypothesis. That is the experiment to determine if does or does not change. So for this, we have to define. Can you change the place? You can define two hypotheses, generally defined, something called null hypothesis. Null hypothesis is usually that changes in independent variable will not lead to any significant change in the dependent variable. So usually that change in independent variable does not lead or will not lead to any change in dependent variable. Any significant, significant dependent variable. This is what is null. Always, null hypothesis you define in such a way that your independent variable will not lead to any significant change in the dependent variable. And then we have to define what is called alternate hypothesis. The hypothesis that changing in or that change in independent variable does change the dependent variable. Okay, we remember these two things. One is null hypothesis. Null hypothesis always defined a change in independent variable will not lead to any significant change in dependent variable. Whereas alternate hypothesis is that the change in independent variable does change the dependent variable. And there is a convention that you can reject the null hypothesis if the value you found would have risen by chance only 5%. If you see, if the value that you get probability of occurrence of that particular incident is a 5% time, then you say that up to 5% time your null hypothesis is valid. If anything less than this, the hypothesis is not valid. The value of Z, so that 95% of the normal distribution lies between. So that means if we saw that our Z distribution, if 95% of the Z distribution lies in the normal distribution, then the value of minus Z to Z will be is 1.96 plus minus 1.96. Within that, 95% of the probability distribution lies. So suppose I want to test a hypothesis, what I have to do? I have to calculate Z, value of Z, and compare with 1.96. If the value is less than 1.96, suppose I find my Z value is less than minus, sorry, get back. If my value is, get back. If my Z value is less than 1.9 minus 1.96 and it is and greater than plus 1.96. Then you have to reject the null hypothesis. Because null hypothesis, you have to see that change in independent variable would not lead to any change in the dependent variable. So then you have to basically calculate the Z value, and then you see where this Z value lies. If your Z value is greater than 1.96 and less than minus 1.96, then you say there your null hypothesis is not valid. So you have to take the alternate hypothesis. So this is what is basically hypothesis testing. So we'll see, we'll take up some, tell you some tables also. I'll show you where you can calculate all these things. This is a Z table. You see, this is basically the Z table. What it says. Suppose I take Z is equal to 1. I'm here, 1 sigma. Okay. 1 sigma, what it says is this. Suppose you have a standard distribution. It is 0. 1 means you have plus minus 1, it is giving the area of this. This is the area. This gives 1 minus this probability. So that means how many are remaining outside this. So that is, if you can see the table, you see for 1 it is this one. That means suppose you have a when you are comparing two values, suppose one Z value falls here. That means what it says, this Z value, and you calculate what is the area above this. Both sides you add them. So that is the probability that your value can come by chance. By chance, we can get a value this and higher than this with a certain probability. Suppose I take Z is equal to, let's say I put a line here, Z is equal to 2. Here and here also, I put Z is equal to 2, Z to minus 2. And area beyond Z is equal to plus minus 2 is basically almost like, 98% area comes here, then only 2%, only 2% will be beyond. Like suppose you 95% area I want to take, that is basically 1.96 minus 1.96. Suppose your Z value, is somewhere, suppose 1.96 minus, and here I put 1.96. That area basically covers 95%. And if your value is, your Z value is coming beyond 1.96, that means the probability of occurrence of that event is only 5% or less. Okay, so that's a idea. So now similarly from this table you can find out, for this is for 1. Then you can find out 1.01, what is the area. That means if your Z is plus minus 1.11, then how much area is remaining? Similarly, suppose I calculate 1.96, I told you, no? 1.9, this line you can follow, 9.96. Yeah, you see, yeah. Only 5% area is remaining. That means if your value is 1.96, then 2.5% here and 2.5% here. So only that much area is many. So you can find out for any value looking into this table, and from there you can find out what is the probability of getting that particular value. And if that particular value is, if it is less than 5%, then you say your null hypothesis is wrong and alternate hypothesis is correct. So that's the bottom line. Okay. So now here I have a problem. I will see how to address this problem. A normal variable x follows a normal distribution. Normal. Yeah. A normal distribution. A normal variable x follows a normal distribution with mu is equal to 6 and sigma is equal to 1.24. Right? Calculate the following probabilities. So this is this table. What it gives, if I integrate the this normal distribution up to certain z value, what is the area it is covering? So in this case, I have to calculate z value. How I calculate the z value? So suppose I want to calculate what is the probability up to x is equal to less than is equal to 8. So my x will now define, how I define my x? My x will be, and I have given the, this is my given, mean value is given, and the standard deviation is given. If this is given, then I can define my z or x as 8 minus mu is equal to 6 divided by 1 point. Okay, 8 minus 6, that is equal to 2 by 1.24. So this will come, I think you can calculate this will come 1.612. So x or z value, whatever you can call it. So if you look now, 1.661, somewhere here. It's 1, 2. So it will be a value somewhere very close to this. So what it says that total area is coming now 0.9463. Okay. 0.9463. That is that means what is the question? A normal distribution, a normal value x follows a normal distribution of mu is equal to 6 and sigma is equal to calculate the following probability. So probability of getting z value less than equal to 8 for such a distribution with the mean value 6 and standard deviation 1.24 is, the value is 9.4. I told you 16126. Yeah, 9462. That's what. Similarly, I can calculate for what is the probability of getting value less than equal to 3. So I can calculate similarly. Suppose I define x is equal to 3 minus 6 by 1.24. If you do this, that will come minus 2.419. So this is minus 2.419. That means somewhere here you want to find out what is the probability, what is the area below this. So that you can calculate 1 minus, then you go to the plus side, that will give you the same value. So you can look here 2.419, 2.419. 2.4, 2.2 suppose. 2.2 is somewhere here. Okay, so 1 minus this will be basically 0.0078. So this value will be 0.007. You can calculate. So that means this area, this value is minus 2.419. From this point area below this will be 0.0078. So you can calculate similarly. Suppose you are given to calculate area between x greater than or equal to 7 and x less than 10. You can find out also calculation. And I also talked last time. You may remember t test and z test. So when you will do z test and when you will do t test, if the population standard deviation is known, like in this case, population standard deviation is known, then you can always do the z test. And if population standard deviation is not known, you have to find out this deviation from your sample deviation. Then you have to use what is called t-test. T-test is, there is a separate table for t-test. So we will see that. So another problem here, you can read this. It says that resting heart rate is known to be 71 beats per minute. So this is a population mean is given with a standard deviation 4 beats. Population, your standard deviation is given. So these two are given means you can always use z test. And with a set of researchers believe that heart rate will increase in man when they are waiting to go into job interview. And when you, because some researchers believe that when you go for a job interview, when you are waiting for your interview, your heart rate will go up. To test, this is a hypothesis. And to test this hypothesis, a group of 9 men attending job interview are fitted with a wireless heart rate monitor to wear on their chest in the hour preceding their interview. 1 hour before their interview, they have a wireless heart rate monitor was fitted, and their average heart rates over this hour are as follows. So there were some 9 people, and their heart rate was like this. So we have a question: A, should a Z test or a T test to be done? In this case, as I told you, you have already population mean, population standard deviation, So if you are these two things, standard deviation of the population is known, then you have to always use Z test. Okay. And then second is conduct the test at 5% level and interpret your result. So what I have to do, I have to calculate the Z value, because I have to do a Z test. So how I will do that? Suppose this one, I will write like this. So in my present case, my mu is equal to 71 and sigma is 4. And if I calculate the x average will come, you can do that, it is coming to be 73.8. Okay. If that is the case, then my P probability of Z will be 73.8 minus 71 divided by Then I have taken 9 measurements. So I have to write my standard error. Sigma E will be sigma by root N. You have to put 4 and 9. And this will give P Z equal to 2.167. Okay. So if I look this table, I will go 2.167. 2.16. This is 2.1. 98, and 7 will be, you can interpolate in between this, so it will be somewhere 29849. But it says that that is the area up to, you could go up to 2.167, then the total probability will be 9849. And then you see what is the probability beyond that, what is remaining here, that you can find that is 1 minus 9849. So that is 0.151. 0.0. This is 0.0.5. So this is 1.5%. So when it, what is we here is it was told that if it is more than 5%, then only you will say that your null hypothesis is correct. But in this case, you are only 0.15%. So that means your null hypothesis is not correct. You have to accept the alternate hypothesis in the sense that really just before the interview, heartbeat of the candidate goes up. So that's a fact. So also you can calculate what is the 95% confidence interval for the population mean. That you should do yourself as your homework. Okay. The next page. This is another problem. But it says that it is believed that university students sleep for 6 hours per night on average. A student sleeps 6 hours per night on average. Below is the data collected. The number of hours sleep per night for each student was averaged over 1 month monitoring period. You have to see, is there any evidence to suggest that this belief is incorrect? Now, what you have to say that whether this belief is incorrect or correct, that is what we have to find out. So these are the sleeping of various students. So again, we have taken how many students? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 students are there. Okay. And if you take the again, you do the same. Here you have to do the t test because you don't have a sigma for the population. Only you have it is believed that 6 hours. So your mu is there. Mu is 6 hours, but you don't have your sigma. Sigma is not given. Sigma you have to now find out. So what you have with you is your sample mean. If you calculate, add and divide by 10, you will get 6.31. Then you have to calculate the standard deviation. That is again xi minus 6.31 by 10 minus 1. If you do this, this will come out to 1.208. Okay. Then now instead of Z, you define what is called T. So T test and your Z test are more or less same, but because of this, because if you take more number of measurement, then this denominator will be changing or same mean. So it depends on the degree of freedom, unlike in the case of Z distribution. So you have a different table here. So we'll see that table. So you can define the T for this. So you know your mean is 6.31 minus population average 6 divided by 1.208. Please remember this. Here you are using 10 minus 1, but here when you want to calculate standard error, you have to use number of event root n. So this comes out to be 2.0115. Okay. So then you see the table. So we have a 10 number of degree of freedom is a number of events minus 1, so 9. So degree of 9, this line you have to do. And your value is 0.8115. Suppose you go this line. This shows the probability, like Z. What is the probability? That is you have a distribution. So you add up this. What is the beyond? So in this case, you see this is 1.383. So I think your value will be less than this is 20%. That means area, if you have a value of 1.383, then T value, suppose you have a plus minus 1.383, then beyond the plus minus 1.383, you have probability of 1.383 is 20%. And this is 5% is if your value is T value is 2.262 plus minus 2.262, then your probability chance probability is only 5%. So it looks from this problem that your probability is much more than 20%. You are somewhere this side, your value. So in this case, you have to you have to accept the you have to accept the null hypothesis. So you cannot reject the null hypothesis in this case because your probability is coming too high for this value. Okay. So similarly, you can look these problems more detail, and in exam you may be finding this type of problem, and I hope you will be able to do. And if you have any doubt, you can ask me. We have 2 more classes. So with this, I think I will be completing your. Also, I talked I think last time about to chi-square fitting that you may be knowing about the chi-square fitting. We can do more examples, but it is better if you understand the basic part of it. That you yourself can attempt if any problem. You can contact me, and I am following the book that is listed in the research methodology class. So if you, I will give you a problem if you want to solve. Go to chapter number 3. That's a good problem. Let me find and tell you. Go to the next. I have a problem for you. Well, I write down the name of the book and the problem. I have a problem for you all. It may be homework. Book is first for science by go to chapter 3, then number 3.5. So this is homework. In exam, you may find this question. So solve the problem number 3.5. If you are not finding this book, then I can anybody who want, I can scan this and send to you, or we can discuss in our next class. Okay, this much for the day. If you have any question, you can ask me. Any question, anybody? Yeah. See in the no question. YouTube. Anybody is having any question? If not, then we will stop here. See you again on Wednesday. Can you upload previous year question? Why you want previous year question? We will discuss. Okay, we will discuss one day. Any other question? Okay, maybe we'll one day we'll discuss these problems so that you prepare for the exam. In the exam, you will have a mixed question. You have short questions. Like if I see the last year question, they are a mixed one. So we had 10 questions on, you have to answer very briefly, 1-2 line. And then you had true and false. So first is 20 marks, 10 question you have to briefly write. And then you write a short note, that is question number 2. Question number 3, there are 10 1-mark questions, true and false, and one was a numerical problem, like we solved today. So we will get a numerical. This is what is research methodology. And similarly, part B, you have to write brief notes and statements and brief notes. Brief answers you have to write. And part C, like part B is basically ethics in research and publication, and part C is IPR, intellectual property right, what Professor Ganguly taught you. There, you have most of the time fill in the gaps and true and false. That's all. So if you want, we can discuss this question. So more or less, this year also it will be similar. And definitely one numerical problem will be there from research methodology. And true and false will be there. And description on one question will be there to describe particular process. Now you have research methodology, you have formulating and clarifying research topic, literature survey, then research design, then you have data analysis, and then finally we will also take up interpretation and write it up. That we will take up in the next class. So all these things you must know what are each part of this research methodology. You should be able to explain each part. Overall, briefly, you should be able to explain that. So that's all. Okay. See you on Wednesday. Okay.